All right, welcome to this week's conversation about transforming manufacturing. My name is Nathan Lesnowski, and we are talking about Industry 4.0 with the SESME organization, Clean Energy Smart Manufacturing. We're going to talk about topics around how companies are transforming their operations and new business in their manufacturing environment, and we'll dig into how companies are looking to make it more efficient. With me this week is John Dyck. John Dyck is the CEO of SESME. Welcome to the conversation today, John.
Thanks, Nathan. It's really a privilege to be here with you today.
Awesome, awesome. So we're going to start off by talking a little bit about what companies are doing in this space, and then we're going to move into talking specifically about how SESME is helping to accelerate organizations in achieving the gains of Industry 4.0. So to set a little bit of the table, I want to talk about how technology is fitting into this broader picture. When we think about technology in terms of above the line and below the line, a lot of transformations happening below the line, where you're seeing migrations of virtual machines to the cloud and the transformation of workplaces and how people interact with each other with content. But an even broader and more significant acceleration to the creation of new revenue or operational savings is the work happening above the line, and the disruption of the marketplace and the transformation of the way manufacturing organizations are looking at their core business. And we're looking at this in the sense that technology is a verb, a part of the fabric of the business that allows us to be able to transform the way these organizations bring their product to market with new revenue, or transform with operational savings the way they produce their products. This is using apps and product development, or it's using data and AI, it's using connected vehicles and products. And we'll talk about all that today when we dig into what Industry 4.0 is. Some scenarios, examples of where companies are seeing these gains are these that you see before you: automation of supply chains, transformation of how they engage their customers with intelligent agents and ordering vehicles, the engagement of predictive maintenance in the manufacturing space to drive efficiency, smart warehousing, the idea of where components are within the warehouse, how I optimize where they are in the paths of them arriving at their destinations, and storage of those components and production of those components. Then the actual production of smart products, the ideas of I'm building something which is engaging my customer, not just in a physical sense, but also in a digital sense, that my product that I've always sold for many years, maybe it's a boat, maybe it's a lawnmower, maybe it's a garage door opener, that product I'm selling and manufacturing becomes a smart product. The idea that customer insights and data as a result of Industry 4.0 is valuable interior to an organization and also for my customers as an asset to them. The broader knowledge I gain from my smart products allows me to provide insights to my customers. The ideas of quality management and understanding gains from my smart warehouse and to produce enhanced quality that's optimized with AI and vision and awareness that mitigates needs for us to add in additional checks later on. Or even things like cycle counting, simple processes that we do every year that when we solve for other problems allow us to optimize those warehouses. So these examples are very rich. We're seeing companies adopt them in varieties of ways and in a great acceleration. What I like to walk through before we get to talking about how SESME helps is let's double click into an example. So one example that's very clear in that we're seeing a lot of companies starting to adopt, and one that SESME is really interested in, is the idea of predictive maintenance, thinking about connected products in the context of the manufacturing space. So examples of where a company might say, hey, predictive maintenance is something I'm going to pursue to improve my organization, is either interior to the manufacturing process or in the product I sell to my customers itself. So in an example of interior might be decreasing maintenance costs associated with the production process and associated with products that are producing the products that I'm ultimately selling to my customers, increasing manufacturing uptime, or even preventing damage or risk inside my environment. I have a company I'm working with right now where they handle glass. And when they handle this glass, it has a high degree of risk. If that were to fall, it could hurt someone. So by understanding vibration, understanding whether the product that's lifting that glass needs to be replaced or maintenance, allows us to mitigate some of those risks that would exist in the manufacturing space. Same sort of example above the line when we're selling something to our customers. Maybe I'm trying to increase service revenue tied to a product I've sold, such as maybe a loader. I sell a loader to my customers. I've wired up that loader, and now I want to ensure that I'm gaining that service revenue by establishing a regular recurring interaction with that customer via predictive maintenance. So this could be both internal to the manufacturing process, driving operational savings, or it could be creating new opportunities for new revenue. So a couple examples of this that companies are taking advantage of. So one example of this might be Heraeus Electronite. They melt metal into metal composites. Their challenge was, hey, how do I take my legacy process where I take a guy with a dipstick and test out what's happening within that metal melting process to make sure I can prevent me from having to throw away that expensive product that I'm building for my customer. Instead, what we did with them is we built a IoT-enabled dipstick that essentially that allows us to be able to monitor in real time what's happening within that metal melting process, allowing us to be able to then provide that input to the people controlling it to limit waste and to limit throwaway and to provide the optimal outcome to the customer. A lot of opportunity in providing a better outcome requires a lot of knowledge, but also tremendous improvement, both in terms of safety of the individuals working with that environment, as well as outcomes. Another interesting example would be what Paragen's doing with producing digital labor and delivery environments with predictive maintenance. My wife and I just had a baby a couple weeks ago, and they were still using like the ticker tape thing to do fetal heart rate monitor. In this environment, it's all digital and provides predictive environment around when there's something happening, when something is, maybe it's getting to a period where the fetus is in trouble, or the fetus is about to be born, the baby's about to be born, and we need to be in a position to be able to catch it. So it allows us to be able to see this in a digital way, to be able to add value on top of the product that was just very, very static, printing off a paper that the doctor can go up and look at and say, hey, yeah, this is what's going on, this is what's going to happen, allowing us to predict, not only just see what happened in the past. Another example would be some of the work that Bergerson-Kneippel is doing. This company inspects the inside of sewer pipes. So what they do is they say, you know what, I used to have a person who would look at the inside of the sewer pipe looking for cracks, and they had to use their expertise to be able to find those cracks. That's a long job. It's a tiring job. It's something that takes a lot of energy. What if I could apply AI modeling to this challenge? This is where we took that video stream and bots inside of these sewer pipes, looked for those scenarios, understood that there was an issue found, and then brought in the individual who was able to provide that input. Another example would be what Brunswick is doing with smart boating. They're producing a product, they have an intelligent manufacturing process to be able to drive better and better boats production, but they also have produced connected products on the boating side that allows them to drive a better customer experience and sell predictive parts, predictive engagement associated with the sold boat. They're a leader in digital boating. So these examples represent either improvement on the manufacturing floor itself or improving the very product that's sold from the manufacturing company. This is where the genesis of connected products and Industry 4.0 is allowing our companies that we're working with, and any company, to be able to create a engagement in the market that's tied to what the market is demanding now, and also the efficiency in their production that allows you to drive enhanced delivery of your products and optimized inventory, demand, and delivery relationships. So quite a bit that's happening here. So let's talk about now how SESME as an organization is partnering to help create these kinds of either efficiencies or driving the opportunity to create connected products within customers. So John, why don't you tell us a little bit about SESME? I mean, many people may not even be aware of what SESME is, what benefit it brings as an organization to the Industry 4.0 pursuit. Tell us a little bit about it.
Yeah, thanks again for the opportunity to have this conversation with you and the broader audience. SESME is the Smart Manufacturing Institute. We are uh, mandated and funded by the federal government um, to drive a specific strategic value proposition into the marketplace. And that's what I want to share with you. The notion that there's cost and complexity inherent in this transition from Industry 3.0, or the way we've done things over the last 3 or 4 decades, to this new environment where, in theory, we're much more connected. We're creating value at a much more rapid and dynamic uh, approach, methodology, environment. So we're funded to drive that innovation in the marketplace, to reduce the cost and complexity of how information can be used to enable value creation. Whatever the desired outcome, and you just walk through a handful of fantastic use cases and scenarios. Whatever those desired outcomes are, they require data. And today, there's still a remarkable level of cost and complexity around how that happens. And so that entire cost chain is something that we're looking at to attack and simplify and reduce both the cost of acquisition, cost of implementation, and cost of sustaining and owning that solution. And so we're a consortium. We bring the brightest minds together, and it's a privilege to work with you and your organization, Nathan, as thought leaders in this the OT world, from the IT world, to bring the best ideas, technologies, methodologies to the marketplace, so we can fund the creation of new ideas, the creation of new technologies, advocate for standards, create de facto standards, and then see them implemented in ways that will benefit not just one manufacturing organization, but many organizations.
Awesome. So tell
The
me, yeah,
core
go ahead.
approach, yeah, the core approach to what we're doing here is under the umbrella of democratization. We are completely convinced that there's a large part of this ecosystem, the Fortune 1000 or Fortune 2000, for whom digital transformation is accessible. They have the means and the experts on staff to drive these types of initiatives into their organization. But there are many that don't. And even for those that can, there is a massive legacy of installed base that is difficult to sustain and makes innovating in new ways and using new technologies prohibitive. So this notion of democratization, reducing cost and complexity for all manufacturers, including the large enterprises, will specifically and aggressively enable small and medium manufacturers to access these capabilities in many cases for the first time, just because the level of cost and complexity has made it largely inaccessible for them. So we talked about democratization in the context of the creation and the acceleration of technology, specific technology foundations, and I'll talk about that a little bit. We talk about the democratization of knowledge. We need more effective and more knowledgeable buyers and implementers and practitioners around smart manufacturing. And that's something that many vendors and implementers today have to do on their own, because the core muscle memory, the core knowledge is not yet mainstream in the marketplace. And so we're funding through academia, through implementers, through technology companies. We are funding the creation of a whole set of tools, models, assessment processes, and methodologies, all the way down to the sort of academic talent pipeline for 2-year community colleges and 4-year academic institutions to build smart manufacturing into existing curricula, into existing engineering programs. And in fact, with Purdue, we're actually even working to create a 4-year smart manufacturing engineering program from scratch, which is pretty exciting. So yeah, and the third piece is the cultural component, right? There's a massive need to help create a more collaborative culture, especially on the plant floor, where in the manufacturing OT world, where there's a lot of proprietary technologies, there's a lot of proprietary means to develop and deliver capabilities on the plant floor. And in many cases, that's not value-added work. And where it's not, we need to provide means to and create a culture of collaboration, culture of working together to solve large, complex problems. This is an intentionally complex slide, but it speaks to the complexities and it speaks to the challenges that most large manufacturers face. In fact, I've been in literally hundreds and hundreds of manufacturing plants, hundreds of organizations, and I don't know of one that doesn't represent this kind of complexity and this set of challenges. With the exception of the red column on the right-hand side, the first 5 columns represent an actual manufacturing systems taxonomy for one of the most mature and most complex manufacturing operations in the world. These systems are installed in almost all of their 68 plants, and each box is its own mission critical level 3 manufacturing system representing, in many cases, vast numbers of servers and large deployed infrastructure in each plant on premise. And every single one of these has its own data store, its own information model, its own user experience. There are interdependencies, interlocks between some of these systems, and yet at the end of every shift, they spend 40 people hours reaching into these systems, extracting data manually, printing Excel reports, Power BI reports for production, quality, and maintenance handoff meetings between one shift and the next. So it's staggering complexity for, as I said, one of the most aggressive and capable manufacturing organizations I've ever known. And so that's the state of the industry. That's the complexity that when a new capability comes to the market, we've been talking about Industry 4.0 for 10 years now. We have great new technologies, but these new products, these new vendors come to the manufacturer and say, hey, we can do all these great things. What they often don't recognize is they just become another box in a very complex architecture that represents the same complexity, the same methodologies, the same costs to implement and own and sustain over time. And so we're essentially working as an organization here at SESME to address that specific set of challenges. And this is a bit of a simple attempt to try to understand where we are in this journey. We use the ideas of Geoffrey Moore from time to time to talk about sort of the crossing the chasm in this space. And the first 3 industrial revolutions, if you look back at the numbers that we have, the first 3 industrial revolutions created a very specific value and productivity curve over time. And as we began talking 10 years ago, this year, it was 10 years ago, we started talking about Industry 4.0 and the 4th Industrial Revolution. The prognosticators predicted $10 trillion of value creation, about 4 of which was going to be in manufacturing. 4 trillion was going to be in manufacturing over the next decade. Well, if you look at the numbers, for the first time in our history as a nation, our productivity numbers didn't just flatten, they declined. And so that productivity curve, that growth and value creation has not happened. And it's really important, we believe, to understand deeply why that hasn't happened. If we're going to achieve our mandate, which is to create a more competitive manufacturing and supply chain in the manufacturing community here in the US, we have to understand this and at a macro level, make sure we're addressing and doing the things that are going to drive productivity the way we believe we can, the way the prognosticators have been alluding to for many years now. But we do have to understand that the current way of doing things isn't sufficient. We've worked to define what Industry 3.0 looks like, and these are the sort of the 7 characteristics of Industry 3.0. And we're here to say that with the exception of a few great organizations like yourselves, Nathan, who understand these complexities and and how to engage the manufacturing ecosystem to address some of these challenges and build in some of the new ways of doing things. The industry at large is still pre-chasm. It's still very much stuck in the third industrial revolution way of doing things. And so as we look at what Industry 3.0 has left us with, and as I stated perhaps somewhat provocatively, that's mostly where we still are. We've tried to also characterize where we need to go. If we're talking about the fourth industrial revolution, and I think revolution is a bit of a stretch for manufacturing, as you know, manufacturers are not quick to adopt new technologies for good reasons we know and understand. But for this evolution to happen, and for us to accelerate this evolution from the old way of doing things to a better future, we have to have something to aim for. And so we've created these, on the right here, these what we call smart manufacturing first principles. This is what smart manufacturing has to be. If we're going to be here 10 years from now with a less complex, less costly approach to manufacturing, it's got to be because it's going to be because we've been intentional about what we're aiming for as an ecosystem. And this is not something a single vendor can do. And so we've declared here that based on our analysis and the many manufacturers we've worked with over the years, that the Fortune 1000 pre-chasm is largely relegated to innovating at the pace of the software vendor ecosystem. And the more mature and larger manufacturing organizations are essentially coming to the conclusion that the Industry 3.0 approach and the way that they've been building software and selling software and implementing software on the plant floor is no longer acceptable, isn't sufficient. They're beginning to diverge and build their own infrastructure, build their own applications, and doing so at their own pace with the deep pockets that they have. So that's unfortunate. They're not doing that because they want to, but I would say 80% of the large manufacturing organizations that we work here fit into that category. They have a vision for the future, but they can't depend on their traditional manufacturing software partners to go there because they're still stuck in that Industry 3.0 approach. And so there's one additional point here to make around the small medium manufacturers, which is that Industry 3.0 kind of left them behind because of the cost and complexity, but that has positioned them in a much more effective way to cross that chasm if we can create a more democratized, less complex, less costly approach to implementing and deploying and sustaining these systems. And so the final piece here is that this speaks to the heart of what SESME is doing to accelerate the ecosystem moving forward with a clear sense of where we are, a clear sense of where we've got to go. How can we engage all of the players in this ecosystem to understand and accelerate our transition to not just better technology, but technology that represents the kinds of interoperability and the kinds of scalability and resilience and so on and so forth that will enable cost to come down and that will enable complexity to be something that a small manufacturing organization that doesn't have costly staff on hand to manage these systems, but that they can still sustain with the existing people and the know-how that they have in-house.
You know, what you're saying here really speaks to me because, you know, so many of the manufacturers that we work with, they have these just complete black box systems that are on the manufacturing floor. Everybody's got them, right? And they're running these really archaic operating systems. They're not secure. Nobody knows exactly how they work. A lot of the vendors aren't even in business anymore. They just keep running the platform because it's tied in with something that they have, right? And this lack of interoperability, lack of transparency, lack of ability for efficient building upon these platforms leads to all these sort of walled gardens and silos that existed in Industry 3.0. And it's expensive and challenging for a mid-market manufacturer, and I'd say even the Fortune 1000 sometimes, to work their way out of that challenge. Like they just kind of leave them there, and it makes it challenging for them to really innovate in that space because there's high risk, and it makes it leaves them in a position where they just kind of let these things run rather than drive the innovation that's possible.
That's exactly right, Nathan. There is so much risk there. There's risk in mitigating it because of, to your point, it's the guy who created. By the way, in that previous messy slide, half of those systems were point solutions that were created for that organization, and half of them were
Mhm.
off-the-shelf products. And to your point, those that were created are likely at least a decade and a half or more old. And if it ain't broke, they're likely not going to fix it. There's just enormous risk there, right?
Running on Windows 95
That's right.
unmanaged,
Yeah, yeah,
jacked into the
exactly.
network. Yeah,
Yeah.
it just presents even just a huge security risk by that position, right? So much opportunity. So tell us a little bit about, tell us more about this is conceptually we understand now, like what specifically is SESME doing to be able to drive this improvement?
Yeah, on the right-hand side, the bottom box talks about de facto standards, data-driven cultures, right? This is the idea that today, uh, I think it's a well understood maxim that most of these projects represent kind of an 80-20 rule. The first 80% of a project is building a lot of infrastructure, building the information model, building the core of the application before I can do the 20% of the value creation, right? That 80% today is always, I'm going to say almost always, done starting from scratch every single time, where the information model is created from scratch and the application is hardwired to that proprietary information model. So there's no portability of application or information model, and there's no interoperability between systems because they all collect, in many cases, the same data from the same source for multiple applications. There's just an enormous legacy challenges with the status quo.
Hmm.
And until the ecosystem gets that, until an organization like SESME can come along with a funding and the ability to actually create some tools that enable this kind of interoperability, so that I, as a domain expert, can build an information model that's totally abstracted from, for a machine or a process that's totally abstracted from any technology stack or a product, a vendor product, until I have the ability to put it in a marketplace where many people can use it, either as shareware or for a fee, uh, we're going to be stuck doing what we're doing. So that's what SESME is focused on, among other things, right? We have the education piece, which is vital to move the culture forward. We have the different efforts around sensing and control and modeling and analytics, but at its core, this problem around interoperability represents, we believe, the biggest step forward for the entire ecosystem. Let domain experts digitize their domain expertise, give them a marketplace where they can actually put it and where the entire world can actually leverage it, create their instance of it, so they can start with something that's directionally complete and refine it versus a blank slate for that complexity and for that cost every single time.
Got it. Yeah, and you also bring even funding to the table to help accelerate these initiatives in projects and customers or in environments or in academia to help drive that acceleration, right?
Yeah, that's exactly right. We have an open RFP right now for roughly $5 million for this next round of projects where that's exactly what we work on and what we try to fund. The creation of these ideas, technologies, capabilities, and then see them deployed. Working with great organizations like yourselves and your clients to deploy these really vital, transformative ideas and capabilities in real manufacturing environments, because that's where the innovation happens. In smart manufacturing, digital transformation innovation is happening too fast for the historic sort of life cycle of R&D and in many cases academia and R&D. It's not that it's not happening there, but so much of it is happening on the plant floor, and that's where we're working to bring the funding as well.
Awesome. Wow. Well, that's a lot of information in a short period of time, but it's such a great opportunity for us to partner and not only, not kind of go after these challenges on our own, right? Which is kind of a core message here, right? A lot of companies, they not only went after them on their own, they used point solutions in Industry 3.0 to be able to get it done. That's a very expensive approach. Doing it from scratch every time, starting from square one and trying to make this happen. SESME is an organization that's partnering with the manufacturing space, partnering with Microsoft and other organizations to be able to create commoditization of Industry 4.0. So I'm super glad that you were able to join us today, John, to talk about your role in helping make this a reality.
Thank you again for the opportunity. This is such a vital topic, and working with concurrency and your ecosystem has been a pleasure. You have the mindset that we're working towards, which is collaborating and working together to solve these vital problems. Thank you.
Awesome. So we are excited to take this into the next steps with you. There are opportunities for us to meet with companies one-on-one to discuss manufacturing solutions, how SESME can be part of that, whether it's in shared information, it's in funding sources, it's in guidance, and how also partners like Microsoft and concurrency can help accelerate Industry 4.0, such as some of the examples we started off with within your business. So let's take that opportunity to meet virtually one-on-one and drive that innovation. A couple things that you should know about that are coming up as well. September 13th through 15th, SESME has the Smart Manufacturing Summit. This is hopefully in person. I will be speaking at it. I know John's going to be speaking at it. What a great opportunity for us to be driving something that's going to create some real impact in the manufacturing space. A lot of opportunity for us to learn more about how SESME is engaging across the industry to be able to do something really interesting and powerful with Industry 4.0. And then also for your technology groups, man, we've got so many great workshops coming up around the cloud adoption framework, leveraging and taking advantage of the cloud below the line, and then also above the line. Some of the scenarios we talked about regarding product development, cloud application architecture best practices, product development, some great upcoming workshops that I want to make sure everybody's looking out for and ensuring that they're relevant people within their organizations are making time to come. Also, certainly check out concurrency.com for recent blogs and videos and other resources. And as you close down the webinar today, please make sure that you connect to meet with us virtually one-on-one. It doesn't cost you anything and should be a great opportunity for us to have a conversation. So hopefully we'll meet with you and have some great follow-ups. Awesome. Thank you again to John and SESME for being part of our webinar today. And also thank you for our guests, for visitors and people watching out on the webinar, for getting information. We hope to meet with you soon. Have a great rest of the day.